going on, everybody? Hit pause here with a tutorial on how to do IK inside of the Unreal Engine. So let me go ahead and demo it. We've got ourselves this gold man here. We've got ourselves this awesome car. Okay, this is like a Honda Aztek. Alright, actually this has a lot more detail than a Honda Aztek does. And when we come in here, we enter the car, and when I look around you can see I'm sat here, and when I turn the steering wheel, my hands are stuck. Obviously a rudimentary version of it, but you can see the theory there. Okay, the arms. Alright, so turn to the right, turn to the left. Okay, so how we do it's pretty easy. I have a vehicle, again, the most awesome vehicle you have never seen. And the vehicle itself is on begin play, sets a steering home variable, and what we do is we pick up a steering wheel. Let's take a look at the components here really quick because they're very important. Alright, here we have the chassis. If you notice how awesome the chassis looks, it's just fantastic. Okay, it's actually Wonder Woman's vehicle, so she's got a little cloaking device on it right now. And then what we have is obviously the capsule component. Okay, the vehicle doesn't move or anything like that. And again, obviously this is just a mock-up of the system where the pilot would sit, right? So we have a capsule component, we have arrow component, we have a mesh who's a hero TPP right now, and what you can see is that if I make it so that he is visible, boom, here he sits like so. Okay, now the reason he's right there is because what I originally did was I activated an anim set for him, this vehicle set. Actually, it wasn't an anim set as much as I used an anim asset. Okay, and you can notice that nothing happens. If I hit compile, okay, he sits there. So I did that so I could basically position him on the seat, so I can get roughly where his bum's going to be. Again, not perfect or anything like that, but from this view, and you know, if you have a side of a car, which I obviously have a really highly detailed side of a car here, you wouldn't really be able to see this anyway, but you know, you would want to position your character properly, right? So what I did was I got a character, just a mesh, because this was based off of character, the vehicle is. That way it could have a movement component such that if I were to drive it, it would receive inputs and have a movement component which replicates well over the server. I do suggest that vehicles and anything you're going to control that needs to be properly seen over the network have a movement component like this. Because if not, then you will be dealing with physics, and physics don't replicate very well, so we made the vehicle like that. And again, this is not even really a vehicle. Okay, it's just like a mock pit. Okay, so I've added this guy just so I can have a position for him, and then I just basically turned this stuff off, but it really doesn't matter because this isn't the character that you're going to see in the vehicle. You're actually only going to see yourself. So I just hide it, you know. And now we have a static mesh, which is the seat. We have another static mesh, which is the back of the seat. Okay, we have a camera, a spring arm that is actually set to a 0 arm length with a camera attached to it, and I just did that just so it would be quick and easy to get it so I can look around with the camera. Okay, now I have a steering column, alright, which is another awesome looking mesh here, very highly detailed, and a steering wheel. Now the steering wheel actually is nothing but the torus, and the material for the torus, this is kind of a side thing. This is just a trick. If I take a look, this material has, hey, dang it, is very simple with the actual image that's on there, but what it has is the ability to, with a push modifier here, I can actually shrink and fatten stuff. Okay, so I can make the steering wheel as thick as I want, and the way that that's accomplished is very easy. It's right here. We just take the vertex normal in world space. You can see here this is just the normal torus, and we multiply that by a parameter, and this is going to effectively act like a push modifier in 3D Studio Max. I'm not sure what they call it inside of Maya, but it would be, or Blender or anything like that, but the push modifier just takes the normals and pushes them in each face's normal direction, averaging them all together, and essentially you are fattening or thinning something out. So I did that just so I can make a quick steering wheel. And then attached to that is an arrow component, and the reason I added the arrow component was simply for visual purposes, just so you can tell which way that the steering wheel is facing. Okay, so you can get the 0 point And then we have actually what we need, which is the anchor left and the anchor left. Okay, anchor right, anchor left. You'll notice that they are, if I look at them, they are actually, the steering wheel is attached to the steering column, and these anchors are attached to the steering wheel. And you'll notice that their rotations are not 0, 0, 0, but their world rotations, in fact, are 0, 0, 0. Okay, so it's very important. If I need to show you guys really quick how to do that, because it's important that they be zeroed out in world, but still be attached here. So basically, what you want to do is you want to put them in position and then attach them. Okay, if you attach them then put them in position, what you'll have to do is zero out. Then you'll end up with something like this, right, where the rotation is actually matching the rotation of the steering column. Here you can see Z that way, Y to the right, X is kind of down, but it's at its angle. This is actually matching that. So in order to zero this back out, basically what you want to do is you want to unattach it once it's attached, and then, sorry, I need to unattach it, and then you can see all of my values get put to what they actually are in the world space. Then zero it out, okay, and then reattach it to your element. So put that to steering wheel, and now you can see that they take on, this is their offset. Okay, so their relative rotation is actually 180, 70, 180. Okay, but their world rotation is 0, 0, 0. Okay, so that's what we want. We want their world rotation to be 0, 0, 0. So that's it for the components. For the graph itself, I am adding a controller input yaw. Okay, so this is just my camera controls. So when I look around, so turn and look around, I am receiving the steering home off of the steering wheel's rotation. I'm getting the relative rotation, and I'm setting that as a variable. Now the relative rotation of the steering wheel, you'll notice here its rotation is 0, 0, 0. That's its relative rotation. Because it is linked to the steering column, its universe revolves around the steering column, and that is what relative rotation is. We want that universe, okay? Because I don't want it to turn when I rotate it. I don't want it to rotate like this, right? Okay, I want it to rotate like this. Okay, so in order to do that, we attach it to something that is rotated like that, and that way our relative rotation here will be 0, 0, 0. Okay, so I store that on begin play so I can kind of have a home variable, which is called steering home. Okay, and then basically this is A and D, right? Move right. We multiply the input by the steering amount, and steering amount happens to be how far in degrees it's going to go. Sorry, actually no. Steering amount is our live variable. I just hard coded it here. This should be like max turning of the. If you were going to promote this, this is the maximum that the steering wheel can go. Because remember, if I press A, this comes out as -1. If I press D, this comes out as +1. So it's either going to be -30 or +30. So we're going to interpret variable back and forth to that with a relatively quick speed and set that constantly. Okay, this will tick. Axes do tick all the time. Okay, and then we set the relative rotation of the steering wheel, but we do a little bit of mathemagics here. So we take the steering home variable, we break out its rotation, and then what we want to do is we want to mess with its own internal yaw. Again, this is related to its own relative space. It does go backwards, so I inverted the amount, and then I just add it to here, make the rotation, set it, and that's how I control the steering wheel. That's all the car is. It's got nothing else to it. Okay, so there's the controls on the car. Now on the blueprints for the character, what I did was I created a vehicle animation blueprint. Okay, and I'm receiving some stuff in the graph here. Basically, I am getting the anchors at all times. Okay, so what I want to do is I want to show you my character first. So when I go, now I'm cheating this. This isn't how you would do this. This actually is Garbaggio. That never got into play. But when you hit E, I get all of the vehicles, car, cockpit, mock-up. Okay, I cast it to car, cockpit, mock-up, or mock BP, and I set a variable. So now I know which vehicle I'm actually controlling. Okay, I align my own mesh, which would be the gold version of my character here. You notice the only difference is I turned him gold. Okay, I basically align that to be the mesh, then I attach it to the vehicle, okay? So I attach myself, which is my gold man, to the car, okay? And no socket or anything like that, and I just keep world position. Then what I do is I swap his anim instance, or his anim blueprint, and you do that by set anim instance class. And you can see that I have, if I just type in hero here, the vehicle anim blueprint, okay? So that's what I've chosen. And then after all that is said and done, I get my own controller and I possess the vehicle. In pawn, you'll notice trails back to as the car cockpit mock, okay? So in the real world, you wouldn't do this. You would say, hey, I got a bunch of these vehicles all in the world. Every vehicle would have some kind of trigger radius to tell the player, hey, this is the, you'd have a current vehicle or something like that, and or even controlled vehicle. You would tell the player, hey, I'm the controlled vehicle. There's more than one of these in the world, because if you notice, there's only one of these guys in the world, okay? So that's what my character does. He basically moves his own mesh into the pilot's position, then assigns a new anim instance, which is going to swap over his entire animation blueprint, so he starts taking on a completely different behavior for animations. Then we possess the car. Okay, and we make sure we attach him to the vehicle, so when the vehicle drives around, he sits there with it, right? So now the real magic. I have one animation in here that I've created, and it's called this vehicle sit IK, and it's one frame, okay? The way that I accomplished that was I posed him in here and I hit record and then I hit stop and I deleted any frames after frame 1. So I just want the pose, right? Everything else I want to do, I want to actually drive with code. So what we do is we get my character, because that's who I am, right? And I pick up the controlled vehicle variable, which again was set. Oh. Well, that's one way of doing it. Okay. Yay. Quite pleased about that. Very happy about that. I didn't do anything, right? I mean, I haven't even touched anything. So let's go ahead and restore. I don't have any source control because I am the only one on my team. And let's go ahead and restore what we had going on here. Okay, back to where we were. So again, got the animation there. So what we do in the event graph is, again, we've stored this on the player. So we pick it up and we cast, and now we can receive. So we get the steering anchor. Okay, those are those two dragon billboards. We get the world rotation and world transforms of these guys, and we break each one of them open. And we just set variables, okay? I got a vector for location, I have a vector for rotation, okay? So I have a position and rotation for the, so what I'm calling it is right IK control, and then right goal rotation. Okay, this is actually the rotation of his hand. Then I have a left IK and left goal. It's the same exact thing. Now the Animgraph has a little cheatery in it. I actually have a state machine, and inside of the state machine I have a state, and inside of the state I have nothing but the vehicle sit IK. So that's all this character has, basically, and fundamentally down to the down at his core is just this. It's just that simple animation right there. So that's all that's telling it to do. Okay. So now in the Animgraph, we have what we call a two-bone IK. Now this is a body IK. I'm going to skip this one for now. I'll show you guys these two in just a second. But here's where we're basically doing the meat of the IK controls. So we use a two-bone IK mode node here. And this is set to hand L. You can drop this down and pick a bone. So the thing is it's a two-bone IK system. So his hand is essentially right here. 2 bones back, 1, 2 is going to end up here. Okay. So his hand is actually this ball right here. Then we've got 1, which is the elbow, and then 2, which is the shoulder. So this is going to go from the hand to the shoulder as the IK. Okay, I'm using world space, and the reason I'm using world space, I'm not using component space. If this character existed as part of the vehicle already, and his bones and the steering wheel's bones and any controls within this, you know, joysticks and pedals or buttons that he needed to push or anything like that were all part of the same skeletal mesh, we would use component space because we could read the socket locations. Unfortunately, in the event graph, from something like just an actor, there's no get component location. Okay, there's get relative location, but the relative location of this guy is actually going to be pretty close to 0. No, the relative location won't be. It'll be based on the center of the steering wheel because that's what it's attached to. The relative rotation would actually be 0. Well, be 180. Be 180. World rotation is what we're actually looking for here. Okay, the world transform. So we do this. The joint target space bone name is actually where the elbow is going to point towards. The location in space towards the where the elbow will point. Now this could actually be an actor, or and you can receive the same way I'm receiving this here. It needs to be a variable, obviously. But if I change this to say like -50 and I compile this, you see how his elbow comes in? Okay, so it's actually -50 is like over here a little bit, so it'd be pointing over here. It's also 50 in the Z. So remember, his root is about right here at his bum, right? So we got -50 and +50 would be about here, and that's about where it's aimed at. Okay, so what I'm doing is I'm pushing it out 150 so that I get the arms kind of extended. Now, like I said, these can be shifted around real time, no problem. You just need to drive this variable, okay, with whatever you're going to do. This doesn't show up here, okay? This is an important note. This is new with 4.6. This doesn't show up if you don't have this set to bone space, if you have it to component space, there's nothing there, it's gone. If you have it to world space, same thing. You need it actually to be bone space or parent bone space. Okay, now the root is the actual name of his root bone. Okay, that's what I drove there, root, which happens to be right here, which happens to be pointing pretty much directly forwards, or it should be anyway. If I use, say, the thigh, that space would be in relation to the way that this thigh is. So Z would be left and right, positive Z would be to his right, X would be forward and backwards, but it would be slightly tilted downwards. Y would be up and down, but it would be slightly tilted forwards if we went negative, and backwards if we went positive, because if you look at the axis here from his thigh bone, okay? But our root bone is Y forward, X to the side, Z up, okay? So when you do the joint target space for the bone name, it's basically like setting the local axis. What direction do you want this axis to actually be? And you can actually see it right there. Okay, when I have this node selected, you can actually see where that goal point is. Okay, here's its root, here's its space, and here's where the goal is. Okay, so that's where the elbow is pointing to. Okay, it's actually quite handy. It's a very powerful thing, and that's really all you need to do. You set the bone, like I said, you want it to be at the start of the chain. You set the space for the target. Again, if it was the knee, right, the knee would be pointing out here, and his leg would be all kind of going this way. And I just do the left hand and the right hand. Okay. Goal rotation is what's going to rotate his hand. So you'll notice I only have rotation here. That's because I unchecked pin on translation and I unchecked pin on scale. They'll show up if I don't do that, but I don't need them. I'm dealing with the rotation. It's going to be additive and world space. Okay, so at the start, when I haven't touched the steering wheel, these values are actually going to be 0, 0, 0. So his hands are just going to be where they are. Once the steering wheel turns, they're going to slightly rotate a little bit with the steering wheel. That rotation is going to get added to the rotation of the hand, and it's going to match. We do the left and then we do the right hand. We finish up by the way, if you're worried about where I got that node, it just appears when you connect a local to component or component to local. Okay, and that's what's driving it working. Everything that you see here is what I've shown you. I don't actually, by the way, I don't need to, the way I'm doing this, I don't even need to be near the vehicle. I can just hit E and I'm in it. Okay, obviously, like I said, you want to handle that differently, and that's it. So the wrist is following those billboard markers, and the hand is following the rotation of those billboard markers. Okay, and it's IKing up towards the body there. Okay. Again, you know, this is not something, you know, that I've really got tuned or anything like that. He doesn't have a gripping position. He's not in a very comfortable pose or anything like that. That's all the fluff. That's all on your guys' end, however you want to do it. And now let me show you the very last thing, this body IK. So I have body IK. If I take this body IK and I move it, you'll see that I can actually tilt the character. Okay, now if it goes too far, it'll pull the hand off of the steering wheel. Okay, you'll also notice that the hand rotation doesn't update here because this is not actually simulating, so it's not picking up that rotation variable yet. The reason that the hands are locked in is because of the default value of this, okay, which is just Z and the 200 in the Z here. Or, yeah, sorry, that would actually be this. The default value is here. Okay, I just copied the rotations from the markers, okay, their world location. So we can reset this. If I move this down, you can see that I can actually get him to do what we all wish we could do. Walk, walk, walk. So I keep it kind of high up, okay, at about 200. I don't know if I look at this, you don't really see that location, but it's like somewhere up here. So it's pointing towards some, you know, arbitrary point up here. It won't stretch unless you actually tell it can, but I don't want it to. So this right here can lean left and right and tilt forwards and backwards. If you wanted to, you can twist it. Now the copy bone exists because the IK, okay, huh, right, yeah, what? I'm not laughing. What? No, Captain. Okay. If I disconnect this and I fiddle with his IK, the IK doesn't actually control any rotations. Let me compile it. So you'll see what his body does. Okay, if I move it like this, okay, I'm only moving the top bone. Now the IK here is actually starting at spine 3. Now if we take a look at this character, okay, he's got spine 3 is actually right here. 2 bones back from that is spine 1, okay, which is just above his pelvis, okay, the pelvis here. So if I had just started it with spine 2, okay, we take a look. Okay. You see what happens here. Spine 2 is actually going to drive the rotation. So, hey, anybody, wait, did you guys hear that? What was that sound? So, we could tell the pelvis to not move, but so that's why I chose spine 3, so that it didn't propagate down, okay, to the actual pelvis. Because remember, now the pelvis is part of the IK, so that's why I chose spine 3. Goes up one more. We compile that, and again, what this does is just moves it, right? It's just moving spine 3. It's not actually rotating it. So what I do is I pick up copy bone, and what this does is I've only got checked off rotation. Spine 3 is going to take on the rotation of spine 2. So as soon as I compile that, so those two rotations match. Okay. Now you could have it, you could drive this in a more interesting way. Obviously, you could make it, you know, be a little bit more. If I wanted to, I could say, just throw this in here. I'm probably going to crash again, right? Fiddling around. Let's say that the pelvis is also going to pick it up. Now I should probably get that fart behavior, right? Okay, so see you got the pelvis is picking up the rotation as well. Okay, so it just copies it, alright, before it updates the pose. So it tends to work okay. But I don't want that. I just want it like this. Alright. Now the one way that you can drive the position of this, because you might think, well, why do you need to move the body around? Well, there's a couple of reasons. Number one, he might take a high G turn or something like that, right? He's going really fast and he makes a real sharp left, and you need to rotate him, this way, as he's driving, right? There's nothing stopping you from saying keeping the head vertical or something like that. But one of the really handy things that you can use to drive it in the event graph here is this node here, which grabs the current orientation and position for the HMD. If positional tracking is not available, device position will be a zero vector. Okay, so what is an HMD? An HMD is a head-mounted display, which is like the Oculus Rift or the whatever other ones out there, right? I think Oculus Rift is the only one that I know of, the name of anyway. I don't have one, so I can't demo it, but it does work. The Oculus Rift does in fact take over the camera as long as you have added I don't know if I crashed before I added that, but what you can do is add a blueprint. To get the Oculus Rift to work, one of the main things you got to do is you come over here and you type camera. You need to add a player camera manager, and in that player camera manager you want to go to the defaults and you want to check off follow HMD orientation. So you fire that off, okay, and then your player controller, which I don't have one, we'll call this HMD, we'll call this VR camera manager. So once you have this, that thing takes over your camera. We can add another one based on player controller, and we'll just call this car PC. What you do is in the defaults here, you go to the player manager class and you pick up, say, the VR camera manager. We compile everything together, we save everything, and now the camera has control. So what the VR does is essentially gives a device position and rotation, which is locked in world space. So essentially, you sitting in your chair, your world is the space, okay? So wherever you rotate your head, if you tilt it to the right, you get some roll. If you push it forward, you get some forward momentum. If you tilt down, you get pitch, right? If you look left and right, you get yaw. So these can be read and used. So driving this body IK controller here would be me driving this variable. Okay, so as you leaned, you would actually be moving the camera around and would be moving his body around to follow with it. So as you leaned, and if you look down at yourself, you would actually see your character lean, and you would always have your head over your shoulders no matter where you looked. The immersion level goes up to frickin' 2000, and everybody thinks it's awesome. It's as confirmed, I've confirmed with a buddy that it does work because he has the VR headset, and it is awesome. I saw it in action and we were giggling like little schoolgirls who just got their first I'll let you guys fill in the blank there. So that's it. That's IK. It's pretty simple. It's just a 2-bone IK system. The main thing is we need to get something to control where that IK handle is actually going to be. Now the downsides, number one, it's a 2-bone IK system. It doesn't go any further than that. So if your character has an elbow bone, which all of mine do, and I have like 900 animations already completed over the last 10 years, I can't really use this system unless I can figure out some kind of trickery to go from like the wrist to the elbow and then the forearm to the upper arm, and try to figure out some kind of blend between those locations to get it all to work. Because like I said, we're limited to 2 bones in the IK chain. All you do is pick the root, you pick the top bone, and it just goes back 2 bones and figures out where you need to go from. That's the best IK we have. Okay, it's great for characters that have no elbow bones, great for characters that have no knee bones. Wouldn't work for a tail, wouldn't work for a whole lot of other stuff. If your character has 19 spine bones because he's a dragon or something, or a snake, and you really wanted to, you could do a crafty system of IKs down that chain. I think, and do some kind of sine wave motion as the character animates. But in this case, the character is very simple. Actually, to be honest, his skeleton's not simple, and I don't want to be mean about this, but this is the most broken character rig I've ever seen in my life. It's impossible to work with. It's impossible to animate. It takes on motion capture very well, but his pelvis is actually flipped backwards from the world. His legs have the axis pointing a complete opposite way from a normal rig. So if you align a cat rig to this, his body's facing the opposite direction and his legs are going up behind him, up through his ass. So his legs would actually be going up this way while his whole pelvis is flipped that way to behind him. I tried to make a cat rig for everybody to make animating him easier and get different types of walk cycles, and once I lined everything up to this guy's skeleton, I realized it was futile. This character, I don't know how they're doing it with all of their systems. I'm assuming retargeting and all that stuff, but it was very, 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 very unworth even attempting on my end anyway. I don't need it, and I was just doing it to be nice to people, and I said, okay, I can't do this. This thing is not right. It also has twist bones at pretty much every joint. There's a twist bone here, there's a twist bone here, there's a twist bone here, and there's a twist bone here. I think there's a twist bone here. I think there's a twist bone in the pinky toe, which you don't need. There's a twist bone on his nose. There's a twist bone on the back of his head. There's a twist bone on his dick. There's a twist bone in his butthole. They've got a twist bone like literally everywhere for some weird reason. I understand what they're used for, but I don't think you need them everywhere. I don't think you really need them in the ankle and things like that. But yeah, so this, like I said, while this character is actually relatively basic, he's convoluted as all hell, and overblown for no reason, because he is in fact a wooden amateur, not an amateur, but a wooden armature. Okay, that's all he really is. It's just one of those things that you stick a little piece of wire up his ass, and then you pose him, and then you look at him while you draw your comic books and stuff. You know, it's one of those guys. He doesn't even need fingers. He should just have those half domes for his hands. He doesn't need eyes or anything like that either. But I'm not crapping on the model because it's useful for demoing all kinds of stuff and prototyping, and it does, like I said, pick up the animation systems that they're using, like mocap and all that stuff. Picks that up very well, and it can be retargeted. But in the specific case of trying to line him up to cat, everything is backwards. Everything is backwards from Max's system. So maybe the problem isn't this guy. Maybe the problem is Max's cat rigs are stupid. I don't know. I'm not the guy who made either one. I'm just the one who tried to make them the same, and it ain't gonna work. So with that out of the way, that's IK. And IK again is two things. Remember, you want to control the position and you want to control the rotation of the goal, the bone at the goal end. And this is transform modified bone on the hand R here. So that's it. This is HipBoss signing off. Thanks for watching. Hopefully you guys found this interesting. Comment, like, subscribe. Look for Rats on Kickstarter within a couple of days. I'm going to try and launch on February 14th. I could really use everybody's help in getting the word out, throwing some support my way and all that stuff. It's very critical that I be successful on this, and if I don't, I really have no other option than to try again, or keep trying until I am successful. Otherwise, project will die. I'll have to go get a job at Burger Donald's and be miserable for the rest of my life, and I'll never make an awesome game for anybody to play ever. So that's what's at stake. Not much. So thanks for watching, guys, and I'll see you guys in the next series.